All right, let's go now to our last example in this section, example number 8. Okay, so what we want to do now is we want to simplify powers of I. And as you can see down here, we want to be able to simplify what is I to the power of 12, what is I to the power of 39, what is I to the power of 16, and you can say I to the power of 1,000. And there is a very quick way of doing this. So, and I'm going to show you why I did this I want thing here in a minute. But here, if we just start with just I, okay, so we've established that I is the square root of -1, right? So if I square both sides, okay, if I square the left side, then that means I square this side, and then I just get -1, right? Well, if I take I to the power 3, okay, so now how do we find what is I to the power 3? Well, I to the power 3, can't we write that as I to the power of 2 times I to the power of 1? Right? Because when we multiply a common base, we just add the exponents. 2 plus 1 is 3. So look at this. I to the power, or I squared, is -1, you see? So this right here is -1. And then we have times I. So really, it's just -I. So we can say that I is the square root of -1. I squared is -1. I to the power 3 is just -I. Or you could also, write this as negative square root of -1, right? Because I is the square root of -1. And then we can say I to the power 4 is I squared times I squared. And I squared is -1. I squared is -1. So -1 times -1 is going to give us a +1. Okay. If we continue this, if we did I to the power of, let's see here, we'll do 6. Well, we can write this as I to the power 4 times I to the power of 2. Well, I to the power of 4 is 1, and I to the power of 2 is -1. Let's see, I squared is -1, so I to the power 6 is going to give us -1. Oops, I think I skipped I to the power 5. Let's just go in here and go, and let's just put in I to the power 5. Well, I to the power 5, we can write that as I to the power of 4 times I. And I to the power 4, we already established that's 1. So that's just going to be I. Okay, so we're not gonna go up to 12 or go up to 39 because we're gonna be here for a long time. But I want you to notice this pattern here. Okay, and I'll try to make this clear here. So we have I squared, I cubed, and I4. So it's I, and then -1, I, and then 1. Okay, and then look right here. So we started with I. And then when we get to the power of 5, it goes back to I. If you do I squared, you get -1. And then I to the power 6 is -1. If we did I to the power of 7, I to the power 7, it's going to follow a pattern. It goes I, -1, and then -I. So basically, these 4 right here are the pattern. It's going to keep repeating. Go I, -1, I, or -I, and then 1. I won. Ah! I won. And that's where we get this from right here. All right, so, I'll show you why that is the particular pattern and how it's useful now. Okay, so to kind of clean this up then, this is what we actually need to do all these down here. We have I, and we have I squared, we have I cubed, and we have I to the power 4. Okay, I is just I squared is -1, I cubed is -I, and then I to the 4th is 1. Okay, so this is what you need to know right here. Okay, this is what's most important, all right? It's the I won with negatives in the middle. I won with negatives in the middle. Okay, so since this pattern just keeps repeating itself within increments of 4, it's very simple now how we can use that kind of logic to do these kind of things here. So watch this. Let's do I to the power of 12. This is how this works here. Okay. So what you do is this. There's two approaches here, and I'll show you both ways. First of all, you can do this. You can say, since it's going to go in increments of 4, let's divide 4 into 12. Okay, so 12 divided by 4 is 3, right? Okay, with the remainder of 0, and that's important here. So I always divide this by 12, and I get a remainder of 0. Okay. The little trick is this, is that this right here has a remainder of 1. This will always give you a remainder of 2, remainder of 3, and remainder of 0. So really this right here, since it has a remainder of 0, the answer is just going to be 1. You say, well, what about this 3 right here? We actually don't care about the whole number. We're just looking at the remainder. If it has a remainder of 1, the answer is going to be I. If it has a remainder of 2, it's going to be negative 1. If it has a remainder of 3, it's going to be negative I. And if it has a remainder of 0, it's going to be 1. Okay. The other way of doing this is you can do this right here. You can say, oh, well, I can rewrite that as I to the power of 4, and then you're going to raise that to the power of 3. Okay, because isn't I to the power of 4 raise that to the power of 3? Isn't that the same thing as I to the 12th? Well, I to the power of 4, if you look right here, is 1, right? So that's 1 to the power of 3, which is just 1. Okay, so that's another approach there. Let's do this one right here. Okay, so let's divide 39 into 4. Okay, so 39 goes into 4 9 times with a remainder. So 4 goes into 39 9 times. So that's 36, 37, 38, 39. So that's a remainder of 3. So again, if we're only looking at the remainder, then that means that must equal negative I. And that's going to be negative I. Okay, so again, we only look at the remainder. We don't care about the whole number. If there's a remainder of 1, it's I. Remainder of 2, negative 1. Remainder of 3, negative I. Remainder of 0, 1. How about this guy right here? Let's divide 16 divided by 4. And that goes into it 4 times with the remainder of 0. So since it has a remainder of 0, then that means it must be just 1. 1. It's pretty good right there. So just divide by 4 and then look at the remainder. Let's go on to these guys over here. Okay, let's divide... go down here. Let's divide 21 by 4. Okay, and that goes into, let's see, 5 times, right? Because that's going to be 20. So 5 times with the remainder of 1, right? 4 goes into 21 5 times, which is 20, and then add 1 more to get 21. So since it has a remainder of 1, I know that the answer is going to be I. Okay, it's going to be I right here. So this answer is I. Okay, so this guy right here, let's just remember, what does it mean to have a negative exponent? A negative exponent means that we have to take the reciprocal. So this is the same thing as saying 1 over I to the 13. Okay, now let's go ahead and simplify this. So 13 divided by 4 goes into 3 times, right? 4 times 3 is 12, with the remainder of 1 to get 13. So since, again, we had a remainder of 1, it's going to be just like this I. So the answer is going to be 1 over I. I replace this right here with I. Again, this right here is 1 over I squared. And we already know what I square is. That's just negative 1, right? Right here. I squared is negative 1. So that's just going to be 1 over negative 1, or just simply negative uno.